Good evening, friends. Let's begin our lecture. So, first of all, I apologize that I was unable to take the live lecture today, and so I'm sending this recorded lecture to you all. I hope you get a chance to look at it before the class on Thursday, so that if there are any doubts or something, I'll be able to clarify them. So already you see that I have made this mistake that this is not lecture 19. In fact, it is lecture 20 and it is May 24th. Don't worry, we are not going to repeat what we saw yesterday. This is something that is new material. So this is a typo. I'll correct that when I post the slides. Okay. So having said that, what we were doing in the last classes, we looked at character arrays and we in fact dissected them to a large extent. We saw what a character array is, what do you mean by a string being stored in a character array, and it's a null terminated string, that is it has a /0 at the end of it, and that is something that the functions that are written in the string.h library expect to be, and that is how these strings are represented. We also just began multidimensional arrays. So what we are going to do in this class is we are going to talk about multidimensional arrays. We'll first talk about integer arrays, and then we will talk about character arrays, which are multidimensional. Okay, so yeah, so this was what we had seen in the last class. So now this is a small recap of the multidimensional array, so bear with me. So when we have an array A, which is a two-dimensional array, we'll be mostly talking about two-dimensional arrays. I'll be talking about three-dimensional arrays and so on a little later. But for the moment, we'll be just dealing with two-dimensional arrays. So we have said already that accessing the elements of a two-dimensional array, or which we typically call as matrix when it is an integer or a real matrix. This is done using these two square brackets aij, where I and j are indices into the array. Remember that these indices being valid, that is they should not cross or should not be out of bounds for the array that has been defined, is the responsibility of the programmer. So that is something that is unlikely to be checked at runtime, and if you access elements of the array which are out of bounds, then you are most likely, in fact if you are lucky, you are going to get a segmentation fault. Okay, as we have said, rows and columns are numbered from 0, and this ordering is row major ordering of the elements. That is, elements of row 0 are all stored together, followed by elements of row 1. This is something that we discussed. In fact, what I want to emphasize is that while we view this matrix as a two-dimensional matrix, or in general when we have multi-dimensional arrays, we view them as three-dimensional arrays, or further, if somebody can imagine 4 dimensions and so on, then you have 4 dimensions. Of course, we can define them in C very easily, but when we define these two-dimensional arrays, there is memory is not memory does not have these 2 dimensions. Memory is flat. So in fact, that is why we have to linearize how this array is going to be stored, and the way it is stored is called as row major form. That is, rows are stored, the elements of the first row are stored contiguously, followed by the elements of the second row. So columns need not be contiguous. For example, 1, 5, 9, 13 are not contiguously stored in an array in the memory, right? So this is the representation of the array. Okay, so as we have seen earlier, there are multiple ways to initialize this matrix. So this matrix 1 is a 3 cross 4 matrix. It is defined specifically so that you see the difference in the number of rows and the number of columns. It has 3 rows indexed from 0, 1, 2, and then it has 4 columns in each of these rows. And this is one of the ways to initialize it. What this initialization shows is that in fact you can, when you are declaring this two-dimensional matrix, and if you are initializing it appropriately, then you are free to leave the first dimension unspecified. It will just infer the first dimension depending on the number of elements that you have initialized, right? So this is how you are going to initialize this. You can also initialize it using double braces, saying that you can have 1, 2, 3, 4 inside a brace followed by the comma and so on. That also is allowed when you are doing this initialization. Typically, we are going to take in large multidimensional arrays using loops. So this is a very atypical case of initializing arrays. Most of the times you are going to read it from some data file or read it, and therefore you will require a loop to read or initialize the array. It's a multidimensional array. Okay, so in any case, you cannot omit column size, and this aspect we will see when we go to functions and when we pass an array or a multidimensional array to a function, or even a single dimensional array to a function. Why can you omit the first dimension of an array? So whenever I'm talking about arrays in this context, today's class, it is multidimensional arrays, but I'll omit the word. When I say matrix, it always feels like a integer or real matrix. So I'm not saying that, but whenever we are talking about arrays, they are multidimensional in this context. Okay, so this is, in fact, we have seen a simple example in the last class where some elements of the array were being changed, and then you were asked to print out something. In fact, it was incrementing some elements and then printing them out, and we worked with that. The only thing that I want to mention is that every element of the array, that is mat of ij. So mat is the name of the matrix or the two-dimensional array. Assume that it is an integer array for the moment, and it has been initialized appropriately with number of rows and calls number of columns, and therefore the indices are running from 0 to less than rows and less than columns. Then each of these cells, mat ij, is simply an integer. So if you want to read in that value, you must use this ampersand, which will allow you to access the address of that ijth entry and then read it. And appropriately, if you want to print it out, then you are going to print it out by accessing the entry mat ij. And just if you want to print it out in the matrix form appropriately, just like what we did in case of printing patterns, then we did not have a new line here, otherwise it will come out as a single column, all of them. We avoided that, therefore it comes out in a row neatly. And observe that there is a space here which allows you to space out the individual elements of the matrix. Of course, you can do appropriate formatting by using the width parameters and so on. I'm leaving it to you. But of course, the new line after this is required, so that after every row there is a new line. Okay, so I'm so used to the interactive class that we have that I'm missing the questions that you would have asked me. But nevertheless, I hope some of you will ask me questions when we meet on Thursday. Okay, so we are going to do some simple exercises with matrices. So that is two-dimensional integer arrays. In fact, we are going to take two matrices, A and B, and add them and store the result in the in the appropriate location. So we are going to assume that the matrix A, or the two-dimensional array A, is a matrix of n1 cross n2 dimensions. And you know that you can add these two matrices A and B only if both their dimensions match. Therefore, B also has to be n1 cross n2. And the result is going to be in C, which is also going to be n1 cross n2 size matrix. There is almost nothing that is non-trivial about this program. except that it is running this nested loop which is required because there are n1 into n2 entries, and these have to be suitably initialized by C has n1 into n2 entries which are suitably initialized. So this loop runs, the outer for loop runs for n1 times, the inner for loop runs for n2 times. So that this requires n1 into n2 iterations to complete this execution, which is Cij is equal to Aij plus Bij. So there is almost nothing that is non-trivial about this, except that you have to manage the indices correctly. Remember that rows as well as columns start with 0, and therefore you should run from 0 up to 1 less than n2, and similarly 0 up to 1 less than n1, right? Okay, so now we go to something which is more interesting, which is multiplication of two matrices. And so for multiplication of two matrices, unless you have seen this program or written this, it takes a little while to think about this program. So we'll go over it a little slowly, but this is completely outside the scope of this course or this topic that we are considering, which is the programming topic. But I would like you to think about this, that and maybe some of you have already thought about and wondered that when we have these when we have these addition of operation defined, we had it very conveniently defined for two matrices which were of the same dimensions, that is n1 cross n2, both of them were of the same type, and then we took element wise, we just added them and we got done with it. However, when we are defining this matrix multiplication, we are defining, I'm sure you know how to do matrix multiplication by hand, and we are going to write a program for that, but we already know how to do matrix multiplication by hand. So I am going to try and annotate this. I hope it works well. Okay, so let me just, okay, so this is the, okay, so this matrix, I'm going to call it the A matrix, and this matrix is going, already I am in a little bit of trouble. So this is the A matrix. This is the matrix A. And okay, so I hope you will allow me to do this. And this is the matrix B that we have, and the result is in C matrix. So this is what is our goal. Now note that the dimensions of these matrix are, the A matrix is in fact a 2, not 2, sorry, it is in fact yeah, okay. So the A matrix is so it is a 4 cross 7 matrix, and this matrix, which is the B matrix, is in fact must have 7 cross something, which is here in this case 1 2 3 4 5 6 7 8 9. So this is a 7 cross 9 matrix, and the result is going to be of course 4 cross 9. So all of us know this. So we are interested in computing this particular cell which we have marked out. and this cell happens to be, so although this can be called as the 2 cross 3 cell, but that we'll not call it because we want to index them appropriately in our language of C programs. So this cell is going to be indexed by the row 1 and the column which is 0, 1, 2. So this is the cell 1, 2. And we are interested in computing this cell 1, 2 of the C matrix, which is this C12, right? This is not the way it is written, C of 1 and square bracket 2. That is how it is written. But for the moment, I'm writing it like this. So all of us know that this is a sum of several products, and these number of products is going to be this n, which is going to be the number of columns, which is 7 in this case. So this is what we are going to find out how to do. So we first need to multiply this entry. Again, this entry, what is it? What is the identifier of this entry? This is 1, 0. Then this is 1, 2, 1, 1, 1, 2, and so on up to 1, 6. Similarly, this 1, 0 entry is going to be multiplied with the entry which is here, which is, this is 0, 0th row, and the second column. So this is, I'll just write this entry here, which is 1, 0, and this is going to be multiplied with 0, 2, and so on. This is the first product that is going to be going to contribute to this. Next, it will be 1, 1, which will be multiplied with 1, 2, and so on. So this is how you want to write this program. So each cell here itself requires you some work. So for the sake of the first time you write this program, what we are going to do is, we are not going to have so many dimensions where these dimensions are, I mean, n1 cross n2 into n2 cross n3. This is not how we are going to write. We are simply going to assume that A and B are matrices which have the same, which are in fact square matrices of n cross n dimension, and we want to multiply them, right? So that is how we are going to write our program. So I'll go to the next slide where we talk about two matrices A and B. Both of them are n cross n matrices. The result therefore is going to be an n cross n matrix, and we are assuming that A and B are initialized appropriately, and we are going to try to compute this sum CNN, right? So this CNN itself has n squared entries, just the same way the sum matrix had n1 cross n2 entries. So we are of course going to run this loop, which is two loops which are nested, which are running from from 0 to n minus 1 and 0 to n minus 1, because these dimensions remain the same. And every time you go into this, you are trying to, so I'll go back to this picture. Every time you go there, you are trying to first find out the value of this cell, which is 0, 0. After this, you are going to go and fill this cell, which is 0, 1, then 0, 2, and so on up to 0, whatever was this earlier. I think it was 9. Okay, so 0, 8 it will be, and that is how you are going to fill up this matrix. But remember that this cell itself requires you several computations. A single cell is not obtained by just looking at two entries. In fact, it requires several products to be computed, and that is what this third loop here is going to do. This third loop, which is running from for k equal to 0 to n, this is going to compute these n products. So in the case of a n cross n matrix, things are very simple, because every cell is a sum of n products where this n is not changing across these different matrices. So that is very easy. In fact, a small exercise for you is to try and write this program for two matrices which can be multiplied. That is, it is n1 cross n2 and B is n2 cross some n3, and then you can multiply them. That is allowed. So uh, yeah. So what I would have done in the class is asked you to fill in code here. So if you are looking at this video, please stop your stop the video being played, stop by, and in fact write down this sum in your notebooks, and then go to the next slide. So I would have liked to take answers, look at your answers and proceed. However, I won't be able to do that here. So I'll just say that this sum, note that this sum is initialized to 0 every time you enter the inner for loop, not inside the third for loop, because that is where you are actually collecting the sum of the products. So you don't want to initialize it here, otherwise you have lost the products that you have computed earlier. And then you are just going to say sum is equal to sum plus something, right? And that something is what I would like you to write. And that, after a little bit of thought, if you have seen it, okay, if you, even if you have not seen it, you should be able to get this, that it will be equal to a of I k into b of kj, and that should give you every product. Remember that this k itself is running from 0 to n minus 1, so it will appropriately select the correct element in the first matrix and the appropriate element in the correct second matrix to multiply, find the product, and then add it to the running sum. So finally, we want to make sure that this is set appropriately. So Cij is finally given the value of sum. Note that this is outside the for loop, the third for loop that we have. So this is something that we are doing outside the nested third for loop, and this happens, this statement happens n squared times, and therefore every element of the matrix C gets appropriately initialized, not initialized, appropriately computed. So what I want to leave you or as a thought, or as some things which are not necessarily in the scope of this course, but I just as general information and curiosity, is that matrix multiplication, again, just like sorting, forms a very crucial part of several computations that we do, and therefore there are several algorithms to compute matrices efficiently. And in fact, if you see this, you are doing roughly n squared things, not roughly, in fact, you are doing n squared computations. And this is some, so whether you can do it in something which is strictly better is something that people keep on researching, and that is something that the best exponent of matrix multiplication is something that is well researched. This is completely outside the scope of our discussions. It is a stream by itself where people keep researching on how to do fast matrix multiplication. The second, which is even more fundamental, is why is matrix multiplication defined in this way? I'm again not going to give any answers for this, but this is something that you should ask yourself and try to find out, right? So this is what, but the programming aspect is fairly clean and straightforward. What I want you to observe is, this is, I think, the first real example where you have written a triple nested loop. That is, we have already seen quite a few examples where we have nested loops. I mean, two nested loops, and we appropriately use while and while, for and while, and so on. But this is the first time we are using a triple nested loop, and this is a good use case of where you need this triple nested loop, right? So with this, I think we'll move in our class to character grids, and so moving away from integer grids, we will move to character grids. They also often occur in practice, slightly less often than what integer matrices or real matrices occur. But I want to illustrate uh, some of the non-trivialities or subtleties in dealing with these character grids, as opposed to strings that we have learned, right? So one of the typical examples that I like to think about, because we are familiar with this, is as kids we have done these word puzzles, right? So we are given this big activity sheet as a very young kid, and there are several names of several countries or rivers or mountains or what you may have, yeah, in these grids, and your goal is to find these quickly in that grid as fast as possible, and sometimes they are so quietly nested there that we don't find them easily, right? But of course they are also done in a clever way. For example, maybe you allow something like a word allowed to wrap around, or the word written in a reverse way, or the word written in a diagonal way, and so on. So we will keep our goal in this lecture very simple, because we are dealing with character grids for the first time. That is, we are interested in finding this pattern CSE. We are not even interested in finding other patterns. In fact, you can ask, okay, uh, can I find other my department short form in this, and we'll see. But at the moment we are just interested in finding the rows and columns which contain CSE. So quickly, if we look at it, this row clearly contains CSE, then this column clearly contains CSE, which is, I'll just try to highlight this, which is okay. So this doesn't get highlighted the way I want, but you see this column which is C, then there is S and E, right? So I am not sure whether there are more CSEs. So this is a CSE which is not in the completely sitting in the row. This is a CSE which is in the reverse way. So currently we are not allowing it. In fact, this is a CSE which is wrapped around, and so on. So we are not going to allow these things at the moment. But so for us, I think the only answers are this row which is indexed as 1, and this column which is also indexed as 1. If I have made a mistake, please excuse me. But these are our answers for this. Again, the exact answer is not important. So before we get into solving this problem, let us just see how to represent this grid. So this grid is conveniently represented as a two-dimensional array, which is where it is a two-dimensional character array, and a two-dimensional array is a set of several one-dimensional arrays. In this case, these are one-dimensional character arrays, as we are aware of. Okay, so just to make sure, if you do print %c grid 23, this is a perfectly valid statement where grid 23 is 0, 1, 2, and 3 is 0, 1, 2, 3. So it is going to print out this character E for us, right? So this is the character at 2, 3. We can say grid 0, 0 is a character B, in which case this C will get initialized to B, and so on. So this is just dealing with grid elements, and these are individual characters. What is grid 3? Grid 3 is in fact a character array, but it is not a string because it is not null terminated. And grid 3 is equal to A, B, C, D, E is in fact incorrect. Why is it incorrect? Because grid 3 is a character array of size 5, which has indices 0, 1, 2, 3, 4. However, this, when you initialize it, first of all, it requires a space for /0. And remember, from our character arrays that we defined, you cannot initialize character arrays after they have been defined. So this definition of grid 5 cross 5, char grid 5 cross 5 or 5, 5 must have been defined earlier, and therefore after that has been defined, you cannot initialize the grid 3 like this. You can initialize individual elements like we have seen, or initialize or modify, but you cannot change them like this, right? So this is incorrect for two reasons. One, it does not have a space for /0. The second is this is not something that is allowed. Okay, so now we come back to this question of finding this finding this string CSC. So before we go there, I want to show something on REPL.it, and which will illustrate a few things. So I'm going to stop sharing the slides. I do not have my TA to see that in fact whether I'm sharing the correct things, but anyways. So I hope that REPL.it is being shared, and as you can see, what I have done here is the same character grid that I have, grid 5 cross 5 has been appropriately initialized. Now what I want to show you is, suppose I want to print this CCSEP. We said that grid of 1 is a character array, right? So therefore, why not print it as printf %s/n grid of 1. So let's try to do that and see what is happening. So let's first compile this program. And if we run this program, you see that what I am printing out is CCSEP followed by ESCEL, which is ESCEL, this part, then SEE, SE, and so on, and followed by something which I cannot even read, right? So why is this happening? This is happening because recall that in the memory, all of this is stored flat in this way. When you are saying %s, it thinks that this is the location at which I have to go. What is grid 1? Grid is not a single dimensional array, it is a two-dimensional array. So therefore, it will have skipped this row, all these entries, and gone to the place where this CCSEP start, the row 1 start, that is the second row start, and it will interpret all of this as a string. So when it is interpreting it as a string, it is waiting for it to see in the memory a /0, right? So whenever that /0 occurs, till then it will think that there is a complete string, and that is what it has to print. So if we in fact run it for a different time, we will, again, we will get some other output, because see, this output is different because this special character y with these two dots is replaced with something which is j and some non-printable characters. If I run it once again there can be something else. So after this, there is a /0, and that is what is being printed. So this clearly shows us that if you just try to deal with these individual grid I elements as strings, it is not correct, because you have not kept a /0 here. Because these are in fact just characters which you filled in, which was okay for your problem. But if you want to think of them as strings, then you need /0s at the end of them for you to be able to print. So this is something that is important, and therefore, although grid of I is a character array, it is not a string. So therefore, string.h functions, if you use as it is, you will be in trouble. So that is what I wanted to bring out using this simple example. I hope this is clear, and if there are questions, you can raise them or we will discuss them in the class. Okay, so I'll go back to sharing my slides. Okay, so what we want to do in this remaining part of the class is to in fact solve this problem where we want to find this string s in this character grid, and this s is, if it is present in a particular row, print out that row id. If it is present in a particular column, print out that column id. And remember, column ids and row ids start with 0. Okay, so just again, the way we have been thinking about it, we are going to write pseudo code, or we are going to make our flow of the program, and we are going to think of writing or think of saying something which is find s1 s2. So what are s1 and s2? They are in fact character arrays. So we cannot as I said earlier, we cannot use directly string.h functions, because these are not null terminated strings, right? So, but however, we can ourselves think of writing this find s1 s2. It's not very difficult. If this we are of course going to say that we don't have currently a mechanism to define functions, but we are going to define functions soon, not in today's class, but in the next class when we meet. So find S1, S2 returns 1 if S2 is present in S1, else it returns 0, and it deals with character arrays. You may also need to give it the size of the two character arrays because it doesn't know where to stop, because these are not null terminated strings. So this function itself may not work as it is, but we have not even defined how, we have not even said how to define a function. However, one more thing is that even if you had a function appropriately defined and implemented, first you have to find out what is how to write a function, how to implement it, and so on. But assuming that all of it is done, you still don't know how to solve it for columns, because these columns are not easily character arrays that we wanted. So a single column, as you see here, right, I cannot even select a single column because these are not contiguously stored. I mean, that is not the reason, but the highlighting doesn't allow me that. But a row I can do that, right? So a single row I can easily highlight. So this is something that is not, I mean, it doesn't solve it. So one thing that one can do is, of course, write that given a grid, you can access the elements of the column, elements in a particular column. However, one of the things that you can do is find the transpose of the matrix. That is, the transpose of the matrix is a grid transpose, in which the rows are transposed into columns, and finding the transpose is not difficult. If you have the transpose, then you can do the same thing on grid T or the rows of grid T and then get the answer, because rows of grid T are in fact columns of the original grid, and you will be done. So what we are going to do in this remaining part is simply write a main program which takes this character grid, which is this 5 cross 5 grid, and computes grid T, which is the transpose of this matrix, matrix or character array, or character grid that you want to call. Now it doesn't solve the final problem of finding the rows and this thing. For that, in fact, we are going to use functions, and when we define functions, we'll solve this problem again. But what I want to tell you is that this is the pseudocode for solving the whole problem. That is, for each row R of grid, find of RS, again, as I said, you need to tell what are the what is the size of R and what is the size of S. Then print the index of R. Then you find grid transpose in grid T, and then this itself is something that we may write as a function. At the moment we are going to write a main program, and then for each row R of grid T, note that it is not of grid, if you find R in that row R the string S, then you print the index of R, which will happen to be the column index in the grid, right? So this is something I want to illustrate, saying that you must develop this pseudocode before you start writing the code, and this is something which is very important. Okay, so having said this, yeah, as I said, we need this concept of writing functions for find, transpose, and so on, which we will introduce when we meet next. Okay, so this is the simple program which allows you to find the transpose. It is the same grid that we had earlier, and grid T is appropriately defined. It has, just note that this grid has a capital T which denotes the transpose, and it has the same dimensions as the original matrix. Now you are going to simply have a nested loop which runs from 0 to 5. The second loop also runs from 0 to 5. And if you take the element ij of this transpose, this thing, it is coming from grid ji, right? And this is all you need to do to find the transpose of this matrix. Okay, so with this, I'm going to stop this lecture. I request you to try out this program just by writing the full thing in main. Even if you don't know how to write functions, it is not very difficult to write this program, that given a grid which is 5 cross 5, find out a particular small pattern which is a smaller character array in that grid, whether it is present or not. You can try to write that program, and when we come next, we are going to start and introduce functions and see how functions will allow us to mm, solve these problems in a very, very nice and modular way. Okay, so with this, I am going to finish this lecture. Please, once again, excuse me for not being able to conduct the live class today, and we'll meet on Thursday.